Hello. I would like to chat with you today about the greatest integer function. The greatest integer function, you have to look carefully at the notation because it almost looks like an absolute value sign, kinda, or like brackets, but it's a little different. This is my best way of drawing it. In the book, it's not quite that exaggerated, but it kind of looks like that. It almost looks like a double bracket kind of thing, or like something from music, or I don't know. Well, that's basically what it looks like, and it pairs every real number x with the greatest integer less than or equal to x. So it's a function. Each input's going to have one output, but it's not one-to-one because you can have more than one input that has that output, has the same output. That's all right. We're not going to worry about that. We're just worrying about the fact that it's a function, and then how does it look? So here's an example. Let's say you have that little symbol, and you see the number 8 in there. It'll pair it with the greatest integer less than or equal to it. So if you do that, and you say, I want the greatest integer less than or equal to 8, well, that would just be 8. 8's the biggest integer, the biggest number that's less than or equal to that. If you have like a negative number in there, which that's allowed, like if you have -7, you want the greatest integer less than or equal to it, well, you can put -7 because -7 is equal to -7. If you have a decimal, like let's say you have something like 6.9, you want the greatest integer less than or equal to that. You don't want to put 7 because 7's bigger than 6.9. And you have to stick with integers like 1, 2, 3, or -1, -2, -3, 0. But so you want the biggest one that's less than or equal. So you'd have to put 6. 6 is the integer just below 6.9. Now, if you're going to do negative numbers, be super careful thinking about what it means to be less than or equal when it comes to your negative numbers. Like earlier I did -7, and that's just -7. But if you had something like -3.7 in there, remember, negatives are kind of opposite of what you might think. So the biggest integer that's less than -3.7 would be -4. So just be really careful with that. If you have a fraction, just think about like you might have to convert it to help you think about it more. So like if you have a fraction 47/5, it might help to think about the fact that 47/5 is the same thing as 9.4. And then you want the next integer below 9.4. So you want 9. That would be your answer. All right, let's take a look at what it would looks like when you go to graph this. All right, so let's just take the standard f of x equals the greatest integer function of x. Well, let's just if you stick integers in there, like -2, -1, 0. Let me do a new chart over here. 1, 2, 3. Those are all going to come back the same integers, because is the equals to part of the definition. But then what you really want to be aware of is what is happening with the decimals in between all of that. Like, let's say you pick a decimal like negative 1.75 in between negative 1 and negative 2. So you want the biggest integer that's less than negative 1.75, and that would be negative 2. And actually, all of the decimals from between negative 2 and negative 1 are going to return negative 2. Like between 0 and negative 1, let's say you have negative 0.25. You want the biggest integer that's less than negative 0.25. So that would be negative 1. Like if you're going between 1 and 2, like if you had 1.36, you want the biggest integer that's less than 1.36. 1. Like if you're between 2 and 3 and you had 2.08, you want the biggest integer that's less than 2.08. So that's 2. So you're going to find out that this ends up being a step function, because you're going to have these little pieces in the graph that end up looking like these steps. Okay, so let me show you why. I wish I had a steadier hand when drawing this, sorry. Trying to carefully eyeball this, make sure I'm spacing it out properly. So each little tick mark I drew is 1. I know the grid has extra lines in between, but you can think about those as halves. Okay, so I put down negative 2, and it's like, well, if you plug in negative 2 into this greatest integer function, it spits back a negative 2, which is right here. But also if you start plugging in things like negative 1.75, that also spits back negative 2. In fact, everything between negative 2 and negative 1 will spit back negative 2. It's when you get to negative 1 that you're no longer at negative 2. Now you're at negative 1. When you start plugging in things between 0 and negative 1, those spit back negative 1. And it keeps doing that for every decimal in between until you get to 0. 0 spits back 0. If you pick decimals between 0 and 1, those are all going to spit back 0 until you get to 1. 1 spits back 1. And it keeps going like this. We did 1.36. Well, in fact, any decimal between 1 and 2 is going to spit back 1 until you get to 2. 2 spits back 2. Then anything between 2 and 3 is going to spit back 2 until you get to 3. 3 spits back 3. And it just keeps going. And notice how it looks like little stair steps. And you can put little dots to show that the same pattern continues. So it's a step function. That's how it looks. Passes the vertical line test. It's a function, and then just keeps going up or down in steps. All right, let me show you another quick example. Just like any other function, you can have stuff going on inside those symbols. Like let's say you have x plus 2 inside of there. Okay, so let's think about what's happening with that. You're trying to return the greatest integer that's less than or equal to whatever's going on inside the symbol there. That's ultimately what you're trying to do. So let's just do a little XY table. And I'm not going to have to draw this too far, because we know that once we get the step pattern, it's just going to keep repeating indefinitely. So we don't even have to go super far right now. All right, let's say you plug in 0. 0 plus 2 is 2. And if you get back an integer, then it just equals that same integer. Let's say you plug in 0.5. You get 0.5 plus 2 is 2.5. Well, the greatest integer less than 2.5 is 2. Let's say you plug in 1. 1 plus 2 is 3. So you get 3. But let's say you plugged in 1.5. 3.5, greatest integer less than that is 3. So this is the same, it's the same kind of step pattern as earlier, except it's shifted. So like at 0, 2, you can put a solid dot, and it doesn't change until you get to 1, 3. So from 0 to 1, you've got this nice solid little horizontal bit, and then it's an open dot at 1, 2, because at 1, you plug in that, you get 3 back. So then you've got this little stair step this way. Or going the other direction, you would have a stair step going like this. Because like, let's say you plugged in -2. Well, -2 plus 2 is 0. And then anything you plug in between -2 and -1 would still spit back 0. When you plug in -1, you get 1. So it goes up. So it just continues in that pattern. If you think about it, like if you think about what the greatest integer function looked like previously, and then think about what's happening here, we added 2 inside the symbol to the x. So that indicates a shift. That indicates a shift to the left 2 units. And that's exactly what happened. If you look at it, ended up shifting left 2 units. Or if you did the greatest integer function with the +2 on the outside, that was shifted up 2 units. So you got some of that kind of action going on. All right, so that in a nutshell is the greatest integer function. Nice little step function. And then just have to think about what's happening at the endpoints and between them, and then when does it step up to the next level. All right, well, thank you for joining me, and I'll see you again soon.